In this video, I want to have a look at complementary events. So complementary events are events that together make up all the total possible outcomes of an experiment. So if we have a look at a few examples, we want to know what the complementary event is of tossing a tail on a coin. So when we flip a coin, landing a tail, well, the only other possible option for that is if we toss a coin or flip a coin and land on heads. So because that's the only other one, that's going to be our complementary event. Our second example says rolling a number less than 4 on a die. So rolling a number less than 4 would be a 1, 2, or 3. So if we want the complement of that, we want all the other possible options. So that means either a 4, 5, or 6. So we could write rolling a 4, 5, or 6. Or we could write it a different way. And we could write it as rolling a number greater than or equal to 4. So both of those statements are the complement of our original event. And the last one is it will rain tomorrow. So if we want the complement of that, well, there's lots of other possibilities for that. It could be sunny, it could be cloudy, it could be windy, it could be anything as long as it's not raining. So probably the best way to write the complement of that is just to put the word not in there. So the complement of it will be raining is it will not be raining tomorrow. So the complement covers all the other possible options. The next part in our notes says the probabilities of all possible outcomes must always, and we're going to write in there, equal 1. So if we have all of our possible outcomes, well, the probability that one of them is going to happen has to be certain, so it has to be equal to 1. So if we have probabilities of each outcome, we add them all together, we're always going to get an answer of 1. So what it says is, this means that when we add all the probabilities together, so it makes it a little bit easier for us to figure out some probability questions. And how we can write it is the probability of an event not happening. So we've got an event E, and we want that to not happen, so we put this little squiggle on the top of it. So we've got the probability of this event not happening is going to be equal to 1 minus the probability that that event will happen. So rather than figuring out lots of different probabilities and adding them all together, we can find the probability of one event and we can go 1 minus that answer. So let's have a look at some examples. Our first one says, what is the probability of rolling a 5 on a die? So we know there's 6 possible outcomes and only one of them is a 5. So we're going to have the probability of a 5 being 1 out of 6. Now the probability of not rolling a 6 on a die. We know that the probability of rolling a 6 is 1 over 6. So we could look at all the other options, or the way we could write it is the probability of not rolling a 6, so the 6 with a little squiggle above it, is going to be equal to 1 minus the probability of rolling a 6, which we know is 1/6. And 1 minus 1/6 is 5 over 6. So for this question, you don't necessarily have to do this. You could look at it and go, okay, well, not a 6 is any of the other 5 numbers. So that means our probability is going to be 5 over 6. And that's a fine way to do it as well. All right, the next one says the probability of winning a game is 0.2. What is the probability of losing the game? So the probability of losing, or we could write it as the probability of not winning, would be equal to 1 minus the probability of winning. Oops, that shouldn't have a squiggle on it, sorry. That squiggle is not there. And we know that the probability of winning is 0.2, so we'll have 1 minus 0.2, which would give us a probability of 0.8. So it's whatever's left over. All right, the last question says, Kate chooses a lolly from a bag containing red, green, and orange lollies. She has a 35% chance of choosing an orange lolly and a 56% chance of choosing a green lolly. We want to know the probability of Kate choosing a red lolly. So we've got these other two probabilities. So the probability of her choosing red is going to be whatever's left over. So we're going to have 1 minus the probability of orange and green. So minusing the probabilities that we already know. So we're going to have 1 minus 35% and minus 56%. Which would give us 0.09. And if we want to write that as a percentage, then we're going to times by 100, which would give us 9%. So that's a quick introduction to complementary events.